All right, so reducing balance depreciation, it kind of uses the same rule as compound interest, all right? We've got this here, here's our recurrence relation. The difference is our value of R is going to be less than 1, right? So it's going to be 0 point something, right? When we've got compound interest, it's growing, so our R value is going to be 1 point something, all right? So you notice when we're finding R, in our reducing balance, we're subtracting, we've got 1 minus R over 100, whereas in our compound interest, we've got 1 plus R over 100, because that investment is going to grow, or that amount of money is going to grow, whereas when we've got depreciation, the value of an asset is going to decrease. When we looked at flat rate depreciation and unit cost depreciation, let's take flat rate, for instance, that rate was set by a percentage of the principal, the initial amount. In reducing balance depreciation, our rate is applied to the value of the asset at that point. All right, so it's not to the initial value, it's as it depreciates, the rate is applied to the set amount of the asset. So let's have a look at an example. So the following recurrence relation can be used to model the value of office furniture with a purchase price of $6,900, depreciating at a reducing balance rate of 7% per annum. All right, so they've already given us our recurrence relation, and remember this value here is R. How did they get that value? Let's have a look. Remember, R, when we were talking in reducing balance depreciation, is equal to 1 minus R over 100, which was our rate, 1 minus 7 over 100, which is going to give us 0.93. That's how they got their R. All right. In the recurrence relation, Vn is the value of the office furniture after n years. Righto. Use the recurrence relation to find the value of the office furniture, correct to the nearest cent after 1, 2, and 3 years. So let's start by writing out our recurrence relation. Remember, we found that just above here. Alrighty, so let's find the value after 1, 2, and 3 years. V1 is going to be equal to 0.93, alright, this is our rule, times V of n. In this case, V of n is our previous term, which was 6,900, our initial investment. Alrighty, so 0.93 times 6,900 is 6,417. To find V2, right, after 2 years, it's going to be equal to 0.93 times V of n, which is our previous term, which was just here, 6,417. Which is going to give us $5,967.81. So we found year 1, we found year 2, time to find year 3. Year 3 is going to be the same, 0.93 times our previous term. Here's our previous term, 5,967.81. And the value of the office furniture after the 3rd year will be $5,550.06. Remember, when we're working with money, we always round to our 2 decimal places. So it's very much like our flat rate depreciation, except instead of decreasing by a set amount set by the principal, here we are decreasing by a set percentage, 7% per annum, in line with the previous year's value. Another hint is you can use your calculator for this. Type in the initial value, press enter, and then go times by 0.93, enter, enter, enter. That will give you first, second, third. Right, so that's easier than doing it the way I've done here, but that's how we map it out. So here's a chance for you to use those calculator skills. Determine when the value of the investment will first be less than $5,000. As you see, when we did it before, this was year 1, this was year 2, this is year 3, all right? This would be year 4, all right? And year 5, the value is going to drop below $5,000. All right, so the question said, determine when the value of the investment will be first less than $5,000. Year 5, 5 years. All right, So to do this, you need to type 6,900, so that's our V0, into our calculator and press enter. All right. Then you type times by 0.93. That's going to bring up, this will actually say ants like that, times 0.93. That'll happen automatically. Press enter once, twice, 3, 4, 5 times, and you find that after 5 years, the value will be less than $5,000. So changing it up a bit, write down the recurrence relation. If the furniture was initially valued at 7,500, that's V0, and is depreciating at a reducing balance rate of 8.4% per annum. All right, we know V0 is going to be equal to 7,500, and our rule is going to be V of n plus 1 equals R times Vn. So we need to find R. Remember, for a reducing balance rate, depreciation, R is equal to 1 minus R over 100. Right, where R is our interest rate, so 1 minus 8.4 over 100 is equal to 0.916. We're going to sub that in for our R value there, and we're left with the recurrence relation, which is V of 0 equals 7,500. Vn plus 1 equals our R value, 0.916 times V of n. There you have it. That's our recurrence relation there. Little hint, make sure that if it is a reducing balance rate of depreciation, it's reducing, so it should always be less than 1. It should be 0.916. R should always be less than 1. If it's compound interest, it should always be greater than 1, so 1 point something. Little hint.